Okay, question 10. We've got a question on mains and immersion heaters, and we can see we've got a battery here. So let me just get a colour. Got a battery here, and we've got mains here. So 230 volts at 50 hertz, AC, and here we've got a direct current. So it says the current, so we've got I is at 14 amps, the power, so we've got P, and we want the resistance. So we're going to need to use IC pink rabbits, and we've just got to rearrange it. And what's the answer to two significant figures? So first job, well, we know that P equals I squared R. They'll give you that in your formula sheet. So now I've got to rearrange. So R's on the bottom, P over I squared, which you can see there. Shove my numbers in, 130 watts, don't need to change U, 14 squared, perfect. Comes to 0.663, so to two significant figures, I need 0.66, done. Next one, the current in the heating element is 8.3, state two differences between the movement of charge. So now I've got to talk about the movement of the electrons. So the movement of charge Q in coulombs in the heating element of the kettle and the immersion heater. So really what it's saying is compare the amps and then compare whether it's AC versus DC. Well, we looked at that before. So we can see this is DC, so the current's going to go in one direction only. Here it's going to go forwards and backwards 50 times per second, 50 hertz. And then the current in the immersion heater is 14, so you're 14 amps. And the other one's 8.3 in the kettle. That's 8.3 amps. So this is going to have a greater flow of charge. It's got more amps, so more coulombs per second. And this one, the current's going to go in one direction, and in the kettle, it's going to alternate directions. It's going to change directions. So model answer, the rate of flow of charge is greater in the immersion heater, 14 coulombs per second compared to the kettle, 8.3 coulombs per second. And I could have put the amps in there. And the kettle uses mains at 230 volts alternating current, so the current changes direction with a frequency of 50 times per second, whereas the immersion heater uses DC, so the charge flows in one direction only, and that's both of those. So talk about the rate of charge, and you can see I've capitalized the rate. You've got to use that word in the mark scheme, and the other one is the direction. Done. And the last one, our old favorite, we've got a plug, and it's telling us all things, and it says there's a fault, so causes the live wire to touch the metal case. Oh dear. So explain the safety features. So clearly we're going to have to talk about the fuse and talk about the earth pin, and it tells us the two things we've got to talk about. And I've told you for the earth wire you had to learn ages ago LRP, TTG, IMC, BL. So it's a low resistance pathway to the ground if the metal case becomes live. So if you touch the metal case, the earth wire, so there's the metal case, the earth wire is going to take it to the ground rather than, if that's your dodgy hand, rather than to you. Because it's easier to go through a conductor than it is to go through your high resistance body, or relatively high resistance body. And then we've got the fuse, and you would have learned TPW, and then a badly spelt H if the current becomes too high. So we've just got to put that into sentences and tidy all of that up. So we're going to talk about the earth, we're going to talk about the fuse. Here we go. So the earth, it's the metal case is a conductor, so an earth wire is connected to the metal case. This is a low resistance pathway to the ground. If the case becomes live, the earth carries current away, so the person does not get a shock, as the metal case has the same very low electric potential as earth. So I'm saying that the case will have the same electric potential as the earth, and therefore you're fine. You're not going to get electrocuted. Now we're going to talk about the fuse. So it's a thin piece of wire, melts if the current is too high, and it's between the live pin and the kettle. So we can see it goes into the live pin there. So this cuts off the main supply, so there's no possibility of getting a shock if the right fuse is fitted. And that, I believe, is that. It certainly is.